So, ladies and gentlemen, it's time to learn about forces. In this screencast, you're going to learn about the types of forces that can act on an object and what to look for to identify whether or not those forces are present. So, first, what is a force? Let's define that. So, on your Avid bookmark, you need to record the definition of a force. So, the definition is very quite simple. A force is a push or a pull. That doesn't sound very scientific, but that's the definition of a force. A force is a push or a pull. Forces can cause different things to happen. Forces can cause motion or deformation or both. Deformation means a change in shape. So um, if something gets pushed and squishes, then that's a deformation. It changes shape. Or if something gets pushed and it moves, clearly that's motion. So those are the two examples of what forces can do. The symbol for force is an uppercase F, and the unit that we use to measure forces in is a Newton. I believe you probably learned that in middle school science. Keep in mind that there's actually two kinds of forces. There are contact forces, and that's pretty self-explanatory. A contact force is a force that occurs when things make physical contact or touch one another, very much like this example right here. The other type of force is a non-contact force, and that's a force that occurs through a field. And so here, this is an example. The magnet is pulling the nail toward itself. It eventually touches it, but there's still a magnetic force acting upon the nail as the nail approaches the magnet. So on this list, we see the different types of forces. We'll go through each one of these individually. I want to go ahead for a second, though, and talk about these last two, the gravitational force and the magnetic force. We just saw magnetic force as a non-contact force, and magnetic forces exert forces on objects that are not touching them by having something called a magnetic field that transmits that force. Gravitational forces are the same. There's a gravitational field that exerts gravitational forces across distances and produces that non-contact force that is a gravitational force. The symbols that we're going to use are going to look like this. We're always going to use an uppercase F for the variable name, and then we're going to use a subscript that tells us the type of force. So Fn matches this first one. Fn is a normal force. So let's go ahead and talk about that one next. A normal force. You have a bookmark to complete on this one. A normal force is a contact force, and it is that support force between two objects where there's a surface that is supporting another one. So it's that support force exerted upon an object that's in contact with another stable object. The symbol is F sub n. The unit is a Newton. The normal force is always perpendicular to the surface. So if we consider this book as the object, then the table is exerting a normal force on the book. And so the table exists as the stable object that produces the normal force that supports the weight of the book. The normal force in this case would be shown by the vector that's just popped up. And the normal force is directed straight upward and perpendicular to the surface of the table. Okay, the next force. Get out your Avid bookmark for tension force. A tension force is a contact force. And a tension force is a force that is transmitted through a ring, a rope, a cable, a chain, a muscle, and it's transmitted when forces are pulled tight on each end of that object. The symbol is an F sub T. The unit again is a Newton, and tension forces are always pulling forces. In this case, with the rope swing, the tension force occurs right here. So the tension force acts straight up along the rope. The next force that you need to include on an Avid bookmark is called a buoyant force. Buoyant force is an upward force that is exerted by a fluid or a gas. The symbol is F sub B, and again, the unit is a Newton. In this photograph, there is a buoyant forces supporting the weight of all of the boats shown in this picture. In this case, we're talking about a buoyant force that is produced by a fluid, in this case the water. And so the buoyant force on this boat is acting straight up. Think of a buoyant force as a force that makes things float. An example of something that's supported by a gas would be something like a hot air balloon or a helium balloon, where the air around the balloon is supporting the weight of the balloon, and in some cases causing it to move. Because remember, forces can cause deformation or motion. Next, let's do the one on friction force. A friction force is the force that's exerted by a surface as an object moves across it or makes an effort to move across it. The symbol is F sub F, and the unit is in Newton. So in this case with the hockey puck, if the hockey puck is moving to the right, then the friction force is acting to the left. The friction force is making it hard for the object to keep moving. The friction force will slow this object down. Similarly, friction can act on things that are not moving. So with this crate on the incline, if the crate doesn't move, there's a friction force acting along the incline and up the incline that is keeping this from sliding down. So friction force. Be sure you're doing a really good job on these bookmarks as you put down the information about the definitions, the kind of interesting or odd considerations about the forces, and do a great job with the images. The images make all the difference on these. You may need to stop the video from time to time so that you can continue writing it down. You're not going to be able to write it down as quickly as I'm saying it. So you may have to back it up even for some of them that we've already gone through. But feel free to stop this anytime so you can finish up your bookmark and do a really good job with it. Okay, next is centripetal force. A centripetal force is a force that causes an object to move in a circle. And predictably, its symbol is an F sub C, and the SI unit, again, is in Newton. Centripetal forces always point toward the center of rotation, and they're actually due to other forces like friction, tension, magnetism, or gravitational forces. A centripetal force is actually an equation or a mathematical construct, and something that you would learn an awful lot about in an advanced physics course. But for now, we'll go ahead and treat it as its own kind of force. In this case, the centripetal force vector is shown here as pointing toward the center of rotation. A centripetal force. Centripetal means center seeking. All right, the next one is an applied force. So an applied force is pretty logical. It's a force that is applied to an object by a person or a machine or another object. The symbol is F sub A. The unit again is in Newton. An applied force is a contact force. So in this image, we can see that the person shown is pushing on the table, and so the applied force is toward the left as the person pushes the table toward the left. Next is an elastic force. An elastic force is a contact force. An elastic force is the force that's exerted by a compressed or stretched material or object upon any object that's attached to it or comes in contact with it. So the symbol is F sub E. The unit again is in Newton. In the top picture, we see something that is clearly stretched. In the bottom picture, this shows how a ball that hits the ground, when it bounces, it's squished, it deforms before it pops back up and changes direction. So remember, forces cause motion and deformation. So this interaction causes a deformation before motion is changed. The vectors shown here, there's an elastic force that acts one way along the top, and then an elastic force that acts the other way too. So we're not going to try to do it for this interaction because it's considerably more complicated, but elastic forces typically act along the line of action of the object being stretched or squished. Typically, we're going to be dealing with rubber bands and springs. Next is the gravitational force. The gravitational force is the force that the Earth exerts on objects to pull them toward the Earth. It's also known as the weight of the object. So F sub G is the symbol for it. So when we talk about weight, we're going to be talking about the force due to gravity. The unit is in Newton, and gravitational forces are always pulling forces. So always remember that F sub g is known as weight, and we will use this symbol when we're talking about weight. We will not use a W. We will use F sub g, the force due to gravity. In this case, it's easy to see that this skydiver is falling down toward the Earth. So F sub g, the force due to gravity, is pulling the person down toward the surface of the Earth. Now, bear in mind that the Earth is not the only thing that can have a gravitational field. The moon, the sun, planets, stars all have gravitational fields that create those gravitational forces that pull toward them. And I believe you've probably learned in your past science classes that the tides on Earth are due to the moon's gravitational pull on the Earth. So this is an example and a reminder that all kinds of things have gravitational fields. The moon has a gravitational field. It pulls on the Earth, and it pulls hard enough that it actually pulls the water toward it, creating our tides. A gravitational force is a non-contact force. It's our first non-contact force. The next one is a magnetic force. So magnetic forces are forces that are either attractive or repulsive forces, and they only apply to ferrous materials or magnetic materials. The symbol is an F sub m. The unit again is in Newton, and magnetic forces can be pushes or pulls. So a magnetic force can pull something toward it, or a magnetic force can repel something as well. So in this picture, it's a bit hard to put in that magnetic force. Magnetic field lines can get quite complicated, but just bear in mind that in this case, we might have a magnetic force that's pulling this direction off this end of this pole of the magnet. So in summary, forces are a push or a pull, and forces can cause motion, deformation, or both. And forces can be contact forces in the case where objects are touching, or forces can be non-contact forces in the cases where those forces are transmitted across fields, like gravitational fields or magnetic fields. The type of forces are listed along this side. You'll notice that centripetal force is not listed in this list. A centripetal force is a force that we will talk about. However, it's not a distinct type of force on its own. Thank you very much. Make sure you've done a great job with these bookmarks. They can be very, very, very helpful to you in this case. When you finish with your bookmarks, go on and do the practice for the vocabulary section of Unit 4A.